that the astronauts read out.
Gravitational effect of those planets.
Hi, I'm John, and this is NASA Now. For future space travel, NASA will incorporate the use of unmanned spacecraft to deliver equipment and supplies to the International Space Station and other low-orbit destinations. So, how can a spacecraft with no one aboard safely rendezvous with another spacecraft? Our guest today will tell us how Project STORRM is guiding the way. That's ahead. First, here's what's happening at NASA Now. In February, history was made on board the International Space Station when Robonaut 2 and Commander Dan Burbank shook hands.
So man meets machine aboard the International Space Station.
This is the first handshake between a human and humanoid robot in space. After the monumental event, a series of tests and exercises followed, with Robonaut 2 including a greeting to the world in sign language. You can follow Robonaut 2 at AstroRobonaut on Twitter. Docking with a space vehicle is no easy task, especially when no one is driving. Thanks to some amazing technology called STORRM, unmanned docking could become a breeze. Byron Meadows, a research engineer from NASA's Langley Research Center, joins us with info about Project STORRM and how lasers and computers are taking control.
We are very happy when we were completing the RPM. You can see the station came up pretty much centered on the orbiter's tail, which was a good sign.
For the last many decades, our astronauts have basically flown by hand. It is somewhat the preferred method just simply because of the experience that a pilot has versus the inability of a machine to make decisions when ambiguous situations come up. One of the key elements of STORRM is that in the future, we'd really like to be able to send unmanned supply ships to the space station. If you can send an unmanned supply ship, you would be able to send out equipment in advance of the humans that might be going out to explore. And in order for those supply ships or advanced vehicles to all be in place when the humans arrive, they need to also be able to interact with one another. And that would have to be done autonomously without the aid of a human. STORRM uses lasers much the way a radar gun would be used by a police officer. If you know the speed of light and you know the amount of time that has elapsed since the pulse left you, then you're in essence looking for an echo pulse coming back. So that's what the STORRM system does. It ranges to the space station to do automated rendezvous and docking. Now, in order to accomplish that, what you really have to do is you have to understand your orientation, your speed and approach angles to the space station at all times. We used pulsed light that was purposely diverged much like a flashlight and a specialized set of targets on the space station that would serve as feedback to a detector or receiver system. That detector then looks at the pattern, then knowing the amount of time that round trip energy took is then calculated or oriented to determine the distance and approach speed to the station. That kind of a system then could be tied into a computer that would fire thrusters, slow the approach speeds, and orient a vehicle so that on its own, it would be able to dock in space. Lasers as an acronym for light amplification through stimulated emission of radiation. And what that boils down to is that what we're used to, which is white light, like what you see coming from the sun, contains all of the colors in the spectrum, and sometimes perhaps colors that are not visible to the human eye. A laser is very specific in that it contains usually one very pure color. That is, all of the photons which comprise the light are all operating at the same wavelength and are also oscillating in phase with one another. Now that's what gives lasers one of their key properties that allow us to use it to measure the things that it interacts with. The speed of light is one of the key characteristics that allows us to use it as an effective tool. One way to look at it is light travels about 13 inches in every billionth of a second. So what we're talking about is the ability to detect differences in time using a detector system that would allow us to be able to calculate that small a fragment of time. For example, if we send out a pulse of light and say 10 nanoseconds, that is 10 billionths of a second later, it returns to us, then we know that it traveled 5 nanoseconds out, 5 nanoseconds back. 13 inches for each one of those 5 nanoseconds allows us to determine the range of the vehicle or the range of the object that we bounced off of.
We've seen how lasers can be used as sensors measuring distance. Here's another way in which lasers assist scientists with their research.
Teachers, you and your class can explore other uses of lasers with the activity Solve the Mystery of the Gases. You will find it on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to visit our Facebook page and leave a comment. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.